Hello everyone, welcome back to another video. In this video, we're going to be conducting the first launch of the TSP FTR series of rockets. Now the FTR series, these three right here, that stands for Fin Test Rocket, and I built them for an experiment of sorts. I have this whole thing explained somewhat on the channel already. I have a build video of these rockets where I go over the design and the build of these, but pretty much the whole thing with these rockets is they are functionally identical, besides, their appearance, of course, and their thin, like cross-sectional geometry, if you will. So if you look at this one, this is the FTR1 block. It has a squared off fin shape, very unsanded. The radius has rounded off fins, and the arrow has airfoil fins. Now, the whole goal with this is we're going to be launching these rockets on, same day. So we're going to try to get the same conditions, and we're going to launch them with a Estes altimeter and with the same motors, and we're going to compare which one goes higher. And in theory, we're going to be able to get a good reading of, what effect different fin cross sections has on max altitude. And so you can kind of make an informed decision on, is it worth grounding these fins? Is it worth sanding it down to an airfoil? In what situation would you want to do what? So that's going to be really cool. Anyways, we're going to try to get a couple more than just one. I'm aiming for at least 3 launches of each of these guys, before I make like a whole overarching video on the entire experiment and we can go over the results. But until then, we have the launches. So these rockets, we're going to be launching them, I think, every time on the A8-3. Or actually, I could switch up the motor, a little bit, and we'll just compare the percent increase or percent differences at the end. But A8-3 motor right here, boom. You guys have always seen them. They come in plastic bags now. It's kind of interesting. And there you go. If you've never seen a A8-3 motor, there we go. Load that up, have the other ones loaded up. We're going to also quickly test the altimeter before we get to a launch. So bear with me a little bit, guys. I do have a timestamp if you do want to skip to the launch. Me talking bores you too much. Let's flip this altimeter on. That's a previous altitude. It's actually a test. All you do, you click that button. Oh, no, that's on off. Sorry. You hold down that button. It'll zero out. Go to 0. Now we're going to do a quick test. All I have to do now, all these altimeters, how they work is a barometric pressure sensor. So pretty much it detects a decrease in air pressure as you go up, and it is able to formulate a estimate of the altitude. And once that air pressure goes back to increasing, then it knows that it reached a max altitude. So we have these small little holes. These are detection holes. And so all we're going to do is just suck the air out of these. I actually had to increase the vent hole size by just a tad bit. But after that last test, we got an altitude of 17 meters. So let us see. Actually, should I change it to feet? I think I should change it to feet just so we can get a smaller and more precise measurement. So the way you change it to feet on the Estes altimeter, if you haven't seen it before, you just hold it down, and that's the 0, 0, and you should keep going until you see unit. And now it'll be feet, 56 feet. There you go. Just click off, and you'll be good to go. And then we'll turn this off until we are ready for launch. So guys, let's see what fin geometry or how much each fin geometry affects altitude in these launches. Who's ready to go see some launches? I am. So let's get on with one. Yeah, that was the highest one. And with that, we have successfully finished the first launch of the TSP FTR series program, whatever you'd like to call it. Very great launch. Really great conditions to launch today. It's a little hot outside, but that didn't affect the launch, of course. Not a clear day, actually. It was projected to be a clear day. I believe it's from the wildfire smoke that's kind of going all over the country right now, but there was no wind. Like it was like 2 miles per hour at peak. It was really awesome. And these rockets, they didn't go super high, you know, I mean, they're 70 grams going on an A motor. They did all go, I will say, lower than the Open Rocket projections said. And that is on my hit part because those simulations that I did, I have the sheets. These ones here, I did get the nose cone accurate. But you see quite a fair bit off. Just some components not, you know, exactly the same weight as they ended up being. And didn't account for the weight of the altimeter. So none of these went as high as they were projected to go. But I did have the altimeter, and the altimeter worked. I don't have the altimeter with me now. We lost it on a flight that came after these today, and that's okay. Such as rocketry. But I do have the results. And so, before I reveal this to you, guys, please go ahead in the comments. Give me a prediction. You know, tell me which one you think went the highest, which one you think went the lowest before I read that out. And okay, in third place today, at 116 feet, we have the FTR2 Radius. A little bit surprising that that was I was expecting that to be the second, but yeah, 116, not too shabby at all. And in second place, at 119 feet, a slight increase, is the FTR3 Aero. Yeah, this guy, we expected him to win. You know, he was seeded to win. So, yes, someone pulled up a big upset because at first place by a large margin was the TSP1 block or TSP FTR1 block at 143 feet. And so this kind of actually is a good lesson for us to have because it goes to show when you're doing experiments trying to get data, there's a reason why you can't just go off one sample because this, if you just went off this, you would think that not sanding, not doing anything to your fins is by far the best. It increases the altitude by a huge margin. When our preceding knowledge, you know, our research that we did before experiment would indicate that is simply not the case. And so there's many conditions that could change. Really the wind, the outside conditions, I don't think changed. These rockets all weigh the same. I did weigh them. And you know, obviously same build. So not like there's a different drag profile. And I don't believe the paint had a major effect. So there's many different things that, you know, could affect this. And rocket motors, you know, they're not going to always be exactly the same. You know, no rocket motor is going to be exactly identical and like the propellant and all that. So the most likely cause of this was that the motor that we used in this one, even though they all came in the same pack, was just a little bit stronger, maybe had a faster burn time, something like that, something that helped kick it just a little bit higher. Because really, I'm not expecting a 30-foot difference in any of these rockets to begin with. But anyways, we'll have to just see. Continue to just do these experimental trials, and we'll just see. Eventually, once we get enough data, we can compile that, you know, and actually get a more accurate reading of the difference. And this launch, this FTR1 right here, would probably be considered an outlier in our data, or definitely be considered an outlier in our data because 30-foot difference between this and like these two, that's just completely unexpected, completely abnormal, and definitely not caused by the fins. Well, I would presume. I mean, you never know, but yeah, it's not because of the fins. I'll tell you that much. But anyways, guys, of course, I hope you guys enjoyed this launch. We certainly have more of these this set of rockets being launched on the way. I was debating on switching out the motors. You know, as long as all three have the same motor, you know, you can just be able to just calculate like the percent change, and that's still on the table. But I did kind of like having these A8-3 motors because, I mean, one, the delay charge was perfect for these, and they just didn't go so high. So there's no risk of like losing one of these, and it would kind of offset or derail the experiment. But yeah, until then, guys, stay tuned for more of these launches and stay tuned for the final video. It'll be pretty cool. I have stuff planned for that. But yeah, I hope you guys enjoyed. Congrats to the TSP FTR1 block for, overcoming the odds as a underdog, a dark horse, if you will, and, getting a pretty spectacular peak altitude. I mean, especially compared to the other two. Come on, guys. Let's up our games. But yeah, guys, thank you guys for watching, and I will see you guys again soon. So stay tuned for more.
Mm-hmm.
2, 1. Three, two, one. Three, two, one. Three, two, one.